Hello, everybody. Welcome to week 6. So we're going to go through fire protection systems this week. And when we talk about fire protection systems, we have 3 different components that we talk about. First thing we talk about is the detection system. Then we talk about the alarm system, and then finally the extinguishing system. So starting with the detection system, we basically got 2 different things that we look for. And the old adage, where there's smoke, there's fire. We look for both of them. So we look for both smoke detection and fire protection. With the smoke detectors, and this is just like the ones you may have in your home, we have 2 primary types, the photoelectric and the ionization smoke detectors. In my opinion, the photoelectric is kind of the simplest of the different options. It basically just uses a light source as a light source and a photocell to see if there's any smoke. It's all enclosed in a way that smoke can get in, and if at any point the light doesn't reach the photocell, it goes ahead and sets off the alarm. So under normal conditions, you have the light from the source, it's registered at the cell, life is good, there's no issues. As soon as smoke gets introduced, that blocks the photocell, light can't get into it, and that causes an alarm situation. The second type, which is probably the more common, would be the ionization smoke detector. And with this one, you have the ions within the detection chamber, and as long as there's no air there, or there's no smoke there, it's all good. We got some positives, some negatives. It's all right there. Everything's good. As soon as smoke gets in, then all of a sudden it changes the electricity within the air itself, and that triggers the alarm. It responds very, very quickly. In fact, so it responds so quickly, a lot of people get upset about it because they'll actually run into issues where it's going off because they're doing basic cooking, maybe steam from a shower, things like that. The good news is it also very quickly resets itself. So as soon as the smoke clears, it turns itself off. I got a little movie that goes through how the ionization smoke detector works. It may be a little more detailed than you may be interested in, but I think it still does a good job of explaining everything. Let's see if this works. There we go.
I find smoke detectors a marvel of engineering. Let me show you how it works. This black cylinder has louvers which guide air into the detector. Now it hides the essential part of the device. Tucked in here lies about 1 microcurie of radioactive americium-241. That's about 0.29 micrograms. That tiny bit of radioactive material generates a small current that makes the detector work. Let me explain how. Air flows between these 2 electrodes. Now, of course, air doesn't conduct electricity, but when alpha particles from the radioactive americium slam into the oxygen and nitrogen molecules that make up air, they knock electrons about, leaving charged gas molecules. The 9-volt battery causes these ions to move, thus creating a current. Now, here it's tiny, something like 100 picoamps, about 100 billionth the current flowing in your home. When smoke enters the chamber, the ions attach to it and slow down and often lose their charge. Both events cause the current to stop, which triggers the alarm. Now, to make such a compact thing work with only a 9-volt battery required the solid-state revolution of the 1960s. Let me show you. If I remove the 2 electrodes, you can see a small integrated circuit. It incorporates a marvelous device called a MOSFET, which can detect those very small changes in current. In the detector, it serves as an on-off switch triggered by the tiny current between the electrodes. Like every transistor, its operation depends on being able to make diodes from semiconductors. Recall that a diode allows current to pass in only one direction because it uses 2 types of semiconductors. A type that uses negative charge carriers and one that uses positive charge carriers. Flip that battery and the flow of charge stops. Now, to build a MOSFET, we take 2 such diodes and put them together so that each is reversed. Now, this seems useless because no current will ever flow through such an arrangement. But engineers embed this diode sandwich into the same type of semiconductor as the diode ends that touch. Then they place metal contacts at the ends of the diodes and on the block of semiconducting material. Next, they coat the diodes with a thin layer of silicon dioxide. Unlike metals or semiconductors, this doesn't conduct electricity at all. On that, they place one more metal contact called the gate, which opens or closes the current channel between the source and the drain. When we create a voltage difference between the gate and the source, it generates a field through the insulating layer that draws the free positive charge carriers toward the gate, opening a channel that now allows current to flow. In a circuit, we use the 9-volt battery to generate a potential difference between the source and the gate. It biases the gate so that the current flows through the MOSFET, thus turning on the horn. So we counter that with a current flowing from the detector. Here is where the ionized gas creates the tiny current between the two electrodes I showed you earlier. That current passes through a large resistor and creates a voltage that opposes the battery, and it shuts down current flow through the MOSFET. If smoke enters the chamber, the tiny current stops. The MOSFET allows current to flow in this section of the circuit, which triggers the horn. Now, to me, this is engineering at its best. Simple, reliable, and inexpensive, and saving countless lives. I'm Bill Hammack, the Engineer Guy.
So, like I said, it may have been a little too technical, or a little more technical than we needed it to, but I thought it still did a really, really good idea of explaining everything that with how the smoke detector works. So we talked about the smoke detectors. Now we're getting into the fire detectors, and we got a couple of different options. The first one would be a fixed temperature detector. So what happens is you have an area here. You have your heat collectors. You have a plunger, as this with a spring attached to it. When this melts or expands or whatever the case is, the plunger will pull down, and then it'll actually make the contact between those two, and they'll it'll make contact between the two leads, and that'll cause the alarm. And that heat collector or the solder will melt, and that heat connector. That is all designed to melt at very, very specific temperatures. Once they melt, the plunger drops down, makes the contact, and you have an alarm situation. The second type would be a continuous line detector, and there's a couple different options for that. But what happens is there's usually two different types of metal. If you look at the one on the top, you have the stainless steel tubing. The one on the bottom, you have the center conductor. You have a thermos, another type of conductor. And what will happen is these will all expand at different temperatures. So as there starts to get heat, one's going to expand, the other doesn't. As soon as they no longer touch, that's going to signal the alarm. The third one is a rate of heat or a rise of heat detector. So it's not going to necessarily notice the specific temperature like the other two might. What this is going to do is it's going to notice how fast the heat changes. And then the fourth different type is the flame detector. And what that does is that looks for the actual light. And it could be a UV, it could be IR. It's going to look for the specific light that's associated with a flame. Usually you'll see these in very high hazard environments, computer rooms, things like that, where as soon as you see a flash, you want to extinguish it right then and there. So that's all the detection system. And then we start getting into the fire alarm itself. And the fire alarm takes the initiating device, the notification device, the fire alarm control panel, and the signaling system. And that all goes together as part of the overall fire alarm. So with the initiating device, we have a couple different options. We see on the right, we have what looks like a smoke detector, and that's definitely an option. Smoke detectors, it could be the exact same type that we were talking about earlier. A lot of times these, instead of just setting off an alarm, they will also be wired back to an alarm panel to notify the central authority. We'll talk about that more, but it'll respond more than that, just that one detector. The other initiating device is the pull station that you see on the left. You break the glass, you pull the handle down, and that activates the alarm. Both of them work equally well. One's automatic, one's relies on a person, but they both work. Once we have the initiating device, then we have to talk about the notification device, and we have a couple different things with that. It could be something as simple as the bell that you see on the left. It could be the speaker and strobe that you see on the right. Very good for areas where you may have someone who's hard of hearing. They can see the strobe and they understand it's time to evacuate. It could be a lot of different things, but this is how you let residents know that they have to evacuate. And this all comes together within the fire alarm control panel. This is where you will see, you can look up here where my cursor is. Here, I'll draw it on here. This section right here is going to give you all the information. What happens is, when it does alarm, oh, sorry about that. Draw it on there again, and I'll leave it up there while I'm talking. So when this does alarm, it's going to give you some information. It's going to maybe tell you what zone it is. Right next to it should be a map that says what zone is what. It could be by building, it could be by floor, but this is where it's going to tell you where the actual alarm is occurring. This is really important, especially once the fire department gets there. That way they know exactly where to go look through the building. They don't want to be searching a million square foot warehouse if they can find really quickly exactly where the alarm is at. If you look inside of the fire alarm, you actually see the electronics. And I really wanted to point out the power supplies in this case. There's two different power supplies. One, it is fed from normal house power, so it's going to be coming in at the normal 120 volts that you have. But then there's always a second power source, a secondary power source, usually a couple of batteries like this, that helps power the system, at least this part of the system, even when you lose full power. It gives you the opportunity to still have some sort of fire protection system in place. And then after we've had that alarm, we have to make sure we know how help is going to arrive. So there's a couple different options. There's local alarms and there's central alarms. And local alarms, they're only going to notify the internal occupants. Think of the smoke detector at your home. That goes off, you know you leave the building. You still have to call 911. Nothing in that system has went ahead and called them yet. A central alarm is a little different, that not only does it let the residents know, but it may also contact the fire department through a central dispatch. This would be like your ADTs or something like that. They notice that there's a fire alarm, they'll go ahead and call the fire department right away for you. Both has its benefits and both has its issues. In an industrial standpoint, there's a lot of central alarms, but not always. If you get into a paper mill or a foundry or something like that, they may have lots of little fires that the fire department doesn't necessarily respond to each and every one of them. So you have to know where you're working, what kind of system you have, and specifically whether or not you need to call 911 on your own, or if that system is designed to do it right away. So we've gotten through the alarm systems, and then we're going to go through the fire sprinkler systems. And there's actually some videos on here that describe this better as well, but I still want to go through this. So there's 4 different types of systems. There's a wet system, a dry system, a deluge system, and a pre-action system. And all of them are similar, but all of them have their own unique little nuances, maybe I should say. They all have their own little specific differences. So the wet system is probably the most common. It's the simplest to operate. It's basically a pipe full of water all the time, waiting to respond. It's always ready to go. So if you look at our picture here, we have our water supply coming in from the stub up right here, and this is all filled with water all the time. So what will happen is these little sprinkler heads, usually they have a meltable fuse, and I think we got some pictures of this at the end. When they melt, that releases this water, and this water can just start flowing out onto the fire. Only one of these is going to operate at a time. I take that back. Only the sprinklers over the fire are going to operate with this type of system. So it's not going to be like the movies show that the fire sprinklers go off and all the sprinklers in the entire room go off at one time. With this type and most types of sprinkler systems. Sorry about that. So that's the way this system is going to work. There's going to be an alarm bell. As you start having some water flow, your alarm is going to start ringing. The downside of this system is that it is prone to freezing. I worked for a company that did did a lot of sprinkler work, and you get this time, or in the winter, it got cold, especially when we get a really, really cold snap, we'd start getting pipes that would freeze up because they wanted to save money. Well, we'll just put a wet system in, then all of a sudden they didn't keep that area heated the way they were supposed to. The next type is a dry system, and it is very, very similar in that the sprinklers are still closed. So to highlight the little sprinklers right here, the sprinklers are still closed, so there's still that fusible link in there, but the rest of the system is charged with compressed air, not water. So you have water up until this point, and then you will have air throughout the rest of this. Then what will happen is as one of these open up, all the air will leak out. This dry pipe valve will open up, and your water will flow through the system and out the sprinkler head. It is a little more complicated than a water system or than a wet system. There is some lag time. It should be less than 60 seconds. It all comes down to the size of the system and how long it takes all the compressed air to flow out. It does take a little more time in testing, inspection, and maintenance than a wet system does, though. The next system is a pre-action system, and it's very, very similar to a dry system in that the system is typically filled with air. It's not filled with water, but it is a little bit different in that it takes some sort of trigger in order to make it work. So, for example, it could be set up that this automatically fills with an electronic sensor, a heat sensor, or a smoke detector. As soon as it gets that trigger, it opens up, the area fills, or the pipes fill with water, and it's ready to go as soon as that sprinkler head melts. That's something that works. Reliability can be reduced because it does rely on some other trigger to get that going. It's not something as simple as there being a fire. It has to also have the smoke, or it has to have the heat, or it has to have that flame detector to make it work as well. And the last time would be a deluge system. In this situation, you have water up into a valve. It works very similar to a pre-action system in that it takes some sort of trigger. The big difference are the sprinkler heads. In this case, these are open. This is not a situation where you have to wait for that fusible link to melt. Water is automatically going to start flowing from there. This is the type of system where you're going to see water come out of everything all at one time. This is for facilities that have need a large amount of water to control a fire. So imagine I saw these mostly when I was in the Navy and we had ammunition areas. If there was a fire in there, we needed to flood the space. We needed to flood it right then and there. And that's how these systems would work. It would just automatically spray. It would open up from every single sprinkler right off the bat. It wouldn't wait for more to open up. So that's the big difference between these, is the fact that the deluge system, it's going to flow through all the sprinklers. The pre-action system isn't. Standpipes. Really, there's 3 different types of standpipes, and what these are used for is to supply water to upper or lower floors. You can have standpipes that go down deeper into the ground as well. What it does is it allows firefighters easier access to water. You can very easily hook up to a standpipe, pump water up to higher floors instead of having to drag hoses all the way through. There's also a lot less what's called friction loss, so you're able to supply water at much higher pressures and higher flow rates. There's 3 types of standpipes: a Class 1, a Class 2, and a Class 3. The Class 1, this is designed for fire department use. It's large, at least 2.5 inches, and you can hook up another large hose up on top. A Class 2 is usually 1.5 inches, and that's really more designed for building residents. So this could be hooked up to your sprinkler system. It also has a hose line to it. So if you start using your hose line, you're going to charge your sprinkler system at the same time. And the last one is a Class 3, and that actually has two standpipes together. You have 1.5 inches and you have a 2.5 inch, and it could be used either one for either building residents or fire department use. And the last thing we want to talk about is the smoke management system. And what this does is it works in a couple different ways to control the amount of smoke within the facility. So if you look at our picture here, this would be our exit. So if people are, in the event of fire, people are trying to get out of the building. What the airflow at this point is going to do is it's pressurizing that stairwell so the smoke can't get in there. So everyone in that stairwell is in a safe environment. The opposite end, and I don't necessarily have a picture of that, you may have an exhaust fan that will be used to help get smoke out of the building. Again, using it opposite of where people are coming out, trying to get out, so you're not harming them. You see it a lot in high-rise buildings. You also see it in correctional facilities. If you look at your county jail, you don't have a giant yard to take the prisoners to. They have to go someplace in the event of a fire. What they'll do is they'll get them into a stairwell. They pressurize it in this way so that the smoke stays out. Actually, at this point, the guards will don SCBAs, and then they'll keep the prisoners there. So it works in a couple of different ways. So that's all I have for this week. I got a couple other videos posted. If you have any questions, please let me know.